Hello everyone, how are you all? I hope all are doing absolutely great and amazing. And today we're gonna discuss about the thermal expansion. Okay. Thermal expansion. So what do you mean by the expansion? Imagine you are take a rod of L length and you will be given a heat into it, that is heat, and the length will be changed into delta L. So why the length is changed? Due to the heat. Due to the heat, the length will be changed. So what you can say, this is called as expansion. When object change his length due to heat, this is called as thermal expansion. When an object changes length, changes volume, changes area, this is said to be the expansion. And if the expansion is due to the heat, then this is said to be the thermal expansion. I hope is it clear? Okay, so now we will do some basic things that you can see in the railway tracks. There have a gap between two rails. Okay, there have a gap between two rails. So why the gaps are in? Why the gaps are in it? This is the question. We can solve all the questions at the last of the video. Okay, so you can see that. Another thing, another demonstration, we're gonna do that. I will take this type of thing and I will take that is a hole and that is a ball. Okay, when I will try to put this ball on the hole, then what is happening here? The ball is not put it. So what you can do, I will give some heat into it. I will give some heat and then the ball passed easily. Why that is? You also can know and this. So there are three types of expansion that you will read in our syllabus. That is, the first one is linear expansion. The second one is surface expansion. And the third one is volume expansion. So first one, you can know this linear expansion. So what is a linear expansion? You can know this. If I will take a rod of L, I will take a rod of length L, then what you can say that if I will giving some heat into it, that is explain of delta L, that I already said. If this is a 1D surface, then the expansion is called as the linear expansion. This is for 1D. Somehow there have the 1D things such as this is a rod. Okay, if they have expansion, then you can also say that that is a linear expansion. So basically you can remember this, but please don't write this on your exam paper, that is 1D. Now this you can say that linear expansion is basically tells about the change of length. That is basically tells about the change of length. Okay, means L, that is change of length. When the length will be changed, means the length will be expand, this is said to be the linear expansion. Now you're gonna see about the surface expansion. Okay, so before reading the surface expansion, we can see a simple example or simple demonstration of that. Is I will take this. Okay, I will take it, and I will give it heat. Then what you can say? That is bent. Same thing I will do that. After measuring the heat, that is bent. Okay, at first when I will take this, that is fully straight, but now that is bent. And if I will taking this and a straight line, then the length of this is change. So this is a type of, let's say you can say that this is a example or demonstration of linear expansion. I will draw the image here of line expansion, that is L and that is delta L. Delta means change. Okay, now we're gonna deal with the surface expansion. Okay, when you can take this type of thing that has a length as well as breadth, length and breadth and length, then this expansion will be called as surface expansion. When you gonna the change of length, when the length, that is change of area, when the change of area is happening, then this is said to be the surface expansion. Is it clear? Now we're gonna do another thing, that is volume expansion. That also you can say that is 2D. That is 2D. That is 2D. Now we're gonna see that about the volume expansion. Volume expansion. Volume. What we can say that that is L means L square. That is L cube. Yeah. Volume means length into breadth into height. Means that is 3D. So I will write here that is 3D. So now I will take a cube. Okay, I will take a cube and I will give in some heat into it. Since there have a change of volume, at first that is the change of length, I will write change as change of length, that is the change of area, and that is the change of volume. Okay, I hope is it clear. Now we can see that I will take a cube and I will give in some heat into it. Okay, I will give some heat into it, and that is expand, and that can change the volume, and this is said to be volume expansion or volumetric expansion. I hope is it clear. Now we're going to see about the coefficient of linear expansion, surface expansion, and the volume expansion. Okay, now we're going to see that how we can measure the linear expansion. So I hope you are noted it now. That is linear expansion. Coefficient of linear expansion, I will write here the coefficient of linear expansion is alpha. Okay, and now we can see that the alpha is the change of length into the first L1. Okay, now I will draw a diagrammatic picture here. The length of this rod is L1, and I will give in some heat into it, and the change of length is L2. Okay, means at first the length of this L1, and after the change the length of this is L2. Okay, now what you can say that L1 into, I will give him the first time the temperature of this is T1, and the second time the temperature of this is T2. So you can write T2 minus T1, and you also say that L2 minus L1 into the L1 into T2 minus T1. You also can write here that is change of length by the initial length by the change of time, into the change of time. Okay, so that you can calculate the alpha, the coefficient of linear expansion. I hope is it clear. Now what is the unit of this alpha? What is the unit of alpha? Unit of alpha, we can say that the unit of alpha is 1 by K, means 1 by Kelvin, because how we can make the units of this, that is the length unit is meter, and here also our length of unit is meter, into this is Kelvin, so that is 1 by K, it is written by K inverse. Okay, that is the Kelvin inverse. I hope is it clear. So now we gonna also you can say the 1 Kelvin is also been 1 degree Celsius is 1 Kelvin, 1 degree Celsius is 1 Kelvin, and then you can say that there have no changes with unit, that is K inverse, that is the unit of this is K inverse. I hope is it clear. Now you also says that what is the dimension of this, because in physics we can make the dimensions of the physical quantities, so we can make the dimension of this is, that is the temperature, change in temperature is theta, so we can say that delta L means length by length into theta means theta. So L cut will be, and we can find that theta is 1 by theta. 1 by theta means theta inverse. Oh, I hope is it clear. F is it clear then? Thank you. अब तो देखो. Now we're gonna see about the. So we can read the linear expansion, the coefficient of linear expansion. Thermal expansion. So now we can know some coefficient of linear expansion in some objects, metals, that is iron. The coefficient of linear expansion in iron, that is 12 into 10 to the power minus 6 in degrees Celsius. Now you can see that is copper, that is 17 into 10 to the power minus 6 degrees Celsius. So these are the important things. Now we're gonna see that is the coefficient of surface expansion. Coefficient of change in area, means change in area, that is surface expansion. Same thing we're gonna do that here. The first area means A2 minus A1, that I will write here, that is beta is equals to A2 minus A1 into T2 minus T1, that you can say change in length by the initial length into the change of temperature. Okay, I hope is it clear. Now we're gonna find the unit of this is same, the length I will not write here, that is delta L by L initial into delta T. So that is length by length into K, length will be cancelled, so 1 by K means K inverse. Okay, I hope is it clear. So same thing will happen with the volumetric expansion. Volumetric expansion. What you can say that volumetric expansion means the change of volume. Yeah, we can say that the V final minus V initial by V initial into T final minus T initial. You also can say that I will take a cube. At the T1 temperature, the volume of this is V1. At I will given the temperature is higher, so at the temperature is higher, the volume will be higher, means T2 and V2. You also write that V2 minus V1 by V1 into T2 minus T1. Okay, same thing, that is V final means the final volume minus initial volume divided by the final the initial volume into the final temperature minus initial temperature. Okay, so now you can notate it. Okay, so the coefficient of this is alpha, beta, gamma. Okay, this is gamma, and this also with same thing, the volume will be cancelled, means the because volume also be as the volume and cancel, and 1 by K means K inverse. Okay, that is the unit of this. I hope it's clear. So that is the thing of thermal expansion. There are three types of thermal expansion. The first is linear expansion, second is surface expansion, and third is volumetric expansion. Now how you can tell this is a linear expansion, this is a thermal expansion, and this is a volumetric expansion. See, I will take a marker, this is 1D. So this if I will give a heat, but this is not a metal, that is have not a property to expand. If I will take a metal and it has a property of expand, so this is, if this is a rod, then they have thermal expansion, they have the linear expansion. If I will take a cube type this, then they have volumetric expansion. If I will take a surface, then they have a surface expansion. Okay, so this is the thing of the thermal expansion. I hope the whole concept is clear. If it is clear, then thank you. Bye bye, see you, take care of yourself and stay motivated, stay safe, stay at home. Bye bye.